Hello? Ooh. Mics are hard. Sorry. So welcome to the almost end of GrafanaCon LA 2019. You've all been lovely, and I hope the workshops today and the single track breakout sessions were able to go into a bit more detail, and I hope that it dug into a little more of what you hope to get out of the conference. We have a small handful of sessions that are going to move pretty quick with a lot of content that I'm pretty psyched about, and then we're going to close just about 5:30. So we're going to power through. Thank you all for sticking around, and I'd like to introduce Dave Cadwallader. I didn't do it right.
No, just trying to get my speaker notes to show up here. One second.
And Dave has a talk that I think we're all pretty psyched about called Explain Like I'm 5. So thanks, Dave.
All right, thanks. Having a Google Doc failure here. Offline mode, I guess, doesn't always work as advertised. Let's try this one more time. Come on, Google Docs. All right, try the old refresh trick. Refreshing, come on. And now everything went upside down. This is just, okay. I always have the technical problems that nobody's actually ever even had before, somehow. Let's try the old unplug it and plug it again. Okay, present. All right, you know what? I'm just going to present from this mode here. Just pretend like you can't see my speaker notes, okay? Because those are supposed to be just for me. All right, deal, everybody? Is that good enough? Okay, perfect. I'm just going to go to mirror my display here. Okay, so this talk is about teaching Grafana to kids and what I learned in the process. But it's also about a bigger topic, about how we can be more empathetic in how we teach fellow grown-ups, and how we can have more fun and hack our own brains to learn as fast as children can. Come on, here we go. Okay. So I do site reliability for DNA Nexus, and we're a cloud computing company that works with genomics. And what we build are tools that allow researchers to analyze petabytes of DNA to try to find those needles in the haystack, such as why did these 10,000 people get cancer, but these 10,000 didn't? And just a quick plug, we are hiring for my team, so if that intersection of genomics and observability sounds interesting to you, please get in touch on my Twitter. My DMs are open. I just realized this means that nobody has to pay for closed captioning of this talk, actually, so this is an added plus. So raise your hand if you know that it's a best practice to rely on alerting, but not human eyeballs for staring at graphs all day. Okay, yeah. So keep your hands up if you stare at the graphs anyway, because they're pretty. Yeah, okay, me too. So I just can't resist, right? There's something so satisfying about that real-time information delivered exactly in a way that gives you that intuitive sense of what's going on. It's just irresistible, right? So as it turns out, it's not just irresistible to me. Whether it's some genetic trait or just a natural draw to pretty colors, my kids would always be drawn to the screen whenever they'd see Grafana on my screen too, and they'd ask, wow, what's that? So we're in the middle of triaging a production incident at work. It's not the best time to give a lesson in Grafana to the kids, but last year when my kids were 5 and 3, I wondered if there was a way that I could teach them about Grafana. And I imagined that teaching them directly these concepts about 95th percentile latencies and HTTP response codes might not be the most exciting way to do it, so I set out to find something more concrete. Now, we're all involved in cloud computing, but maintaining your own physical hardware is just so 1970s, right? But we can all acknowledge that as cool as cloud computing is, it's just kind of boring, right? So all this cool technology exists, but we can't actually reach out and touch it. So anybody know what one of these things is? Shout it out if you know what it is. Yeah, very good in the front row there. So it's a cute name for a tiny little credit card-sized computer that you can get for 30, 35 bucks. And we had a few of these laying around from all these various abandoned experiments I had done. So I thought, hey, it would be cool if we could do a project with the kids. So has anybody ever played this game with a baby where you feed the baby food, the baby grabs the food, they throw it on the floor, the grown-up has a reaction like, don't do that, and then the baby's like, oh, I got a reaction from them. And then what does the baby do immediately? Drops the food again, right? So this is a common example of a developing human brain learning about cause and effect in a pretty mind-blowing time for a baby when they're like realizing, wow, my actions actually affect the world in this big existential way, and that they can manipulate the environment around them. So I thought it would be really cool if we could tap into that underlying cause and effect being something really exciting for kids to teach about Grafana. So one kind of measurement that kids learn to understand from a very early age, when they turn on the faucet and it's too hot and they realize like, oh, too hot, is temperature, right? And too cold, right? So I found some wireless temperature and humidity sensors on Amazon for $10 each, and these sensors communicate using a common radio frequency, 433 megahertz, that's used by a whole lot of other things in your house. And there's this cool little $20 receiver that you can plug into your Raspberry Pi that will actually receive radio frequencies and turn them into digital signals that then you can pipe to a Linux process and do just about whatever you want with them. There's a whole lot of things that we want to do with these that we haven't done yet. You can actually intercept frequencies from airplanes flying over your house and even get like weather satellite data. But for now, we just use this to get the signals from these temperature sensors. So we had a sensor coming to life party with the kids, and we popped the batteries in and watched them transmit a signal. And this is what it looked like when it was showing up on the screen. So every time we popped in some batteries, every sensor would broadcast its own unique sensor ID. So a new sensor ID would pop up, and we'd have the kids say, OK, let me know when you see a new number. And they'd say 9795. OK, cool. Brand new sensor. So we'd write that one on the battery, on the sensor that we just popped the batteries in. And every 30 seconds, these send out a little ping with their sensor ID, the temperature, and the humidity levels. So from there, all we had to do was send that data to InfluxDB and graph it with Grafana, and the kids had their first dashboard to play with. And we placed sensors all around the house to see which rooms were warmer, which were more humid. We live in Colorado, so pretty much everything is zero humidity, dry as a bone. So that wasn't too exciting. But we started to learn about concepts like zooming in and out, understanding the X and Y axis, and plotting lines from those points. So we were beginning to learn the building blocks of Grafana. And it wasn't too long before the kids started to notice interesting shapes. I'm going to try presenter mode one more time. Let's see. OK, there we go. Now we're back in business. Sorry for this. I just realized there's a bunch of noisy background stuff here that I didn't want to show. But the Google gods don't want me to do this, do they? Let's see. OK, I'm just going to go back to this previous plan. That's fine. So we started to see some interesting shapes like this after they'd zoom in for a closer look. And this was a room that we thought was a pretty constant temperature, but it had this pattern. We started to learn about sawtooth patterns. And when we were like, that's interesting. Why is it going up and down, up and down, up and down? We thought that this was a constant temperature. So we used our eyes and our ears, and we listened, and we noticed that whenever the furnace would kick on, we'd have this little increase, and then the furnace would turn off, and we'd have this little decrease. And then so that started to make sense. And this was another example for the kids about making a connection between the environment around them and the data that they observed on the graph. So we also have 2 cats, and does anybody have cats that like to wake them up at like 3, 4, 5 in the morning? Like, I have an emergency, I don't like the way that shadow looks or something. And so we had this problem, and we decided we were going to give the cats their own luxury nighttime accommodations with luxury cat beds, but they would be locked in their special rooms so they couldn't bother us at night. And being in Colorado and having drafty rooms, we were worried that what if they were cold at night, and did these cat beds really work to keep them warm? So we thought, hey, we could actually use Grafana to answer this question. So we put a sensor in their cat bed in the corner inconspicuously, and we graphed Hobbs and Roybus, our 2 cats. And so you can see, they went to bed around the same time, and Roibus, who's the much more fluffier cat, had a much steeper slope towards her peak bed temperature. And Hobbs, who's the short hair, was a little bit slower to get there, but they eventually converged. And we can see that Hobbs actually got up to have a late night snack and then got back in bed. So it was cool to look at this graph with the kids the next day and ask them, what do you think happened here? Why do you think this went down? Why do you think this went up? And it was the kids' first experience looking back at historical data to piece together a story of what may have happened, right? And just like analyzing a production incident by looking at historical data, we don't always know concretely what happened, but we can look at our data to give us clues. And the kids were pretty amazed to learn that this kind of thing, looking at historical graphs like this in Grafana, this is a big part of what I do at work all day, but now it was approachable. So after we had a week's worth of data, we could zoom in and start to learn about trends. And we talked about how the two cat beds were correlated and followed the same shape day after day. And it wasn't long until Bowden was really into playing with the Grafana UI. So I encouraged him, don't worry about breaking stuff, just play with stuff, check boxes, move things around. Let me know if you have any questions. And he discovered the draw modes, these 3 checkboxes here, that allow you to represent the data with bars, lines, or points. And he turned our temperature graph into this. So how many of you have ever stood over the shoulder of one of your coworkers when they're learning Grafana, and you're just like, you see them doing something and it's not the way you would do it, and you say, just let me do it for you, right? Like, I'm the expert, I know what to do. So my first instinct was to say, hey, this is making this graph look too complicated, but I took a deep breath and I said, well, what do you think of this graph? And he said he liked it, so we kept it like that. But we used the opportunity to talk about reasons why sometimes people choose to represent their data with lines and charts and lines and bars and points, and why sometimes it helps the viewer to understand better. But there's not always a right or wrong way to do it. It's more of an art than a science. So this was all well and good, but we were just doing a lot of sitting around looking at graphs, right? So as winter was setting in Colorado and it was starting to get really cold, too cold to play outside, there were fewer nice days for burning energy outside. So I wondered if there was a way that we could actually use Grafana to motivate the kids to get some exercise too. So the kids have this small indoor trampoline that they occasionally enjoy a few bounces on, but I wondered if we could make it more engaging by adding some technology. So we set out to find something that could measure the movement of the trampoline. And we learned about something called an ultrasonic rangefinder, which is a sensor that measures the distance between an object and what's in front of it. And they're pretty cheap. You can buy a 5-pack of them for the price of a burrito. And it works, this looks kind of like a boombox because it actually sort of is, except instead of like thumping bass, it transmits a really high frequency signal that's too high-pitched for human ears to hear. Some animals can, actually cats, we found out. They try to whack it and bite it because it's really annoying, I guess. But then it basically just measures the round trip of how long it takes a signal to bounce back off of something, and then you can send that to your Raspberry Pi. So it's just some physics about an equation of how to measure that. The Raspberry Pi has these nice little pins called GPIO where you can plug in just about any sort of electronics. And so the kids helped me wire this up, and it was really fun. My daughter Zenna and my son Bowden both helped me wire this up. We learned about resistors and making voltages between different devices match up, and we wound up with this. We used something called a breadboard, we learned, that white long thing, which allows you to connect wires without having to solder them together. Decided we probably weren't ready for a soldering iron yet, maybe next year. And I'm a Node developer. There's some great Node libraries for interacting with Raspberry Pis and different sensors. So we wired this up and started just moving our hand back and forth and seeing some numbers changing on the console to represent the distance from the sensor to our hand. So we were ready to wire this up to the trampoline, but first I asked the kids, what do you think this graph is going to look like? Let's make a hypothesis. And Bowden, drawing from his prior experience, enthusiastically responded with a sawtooth. So we set up the sensor and began our next experiment. But before we unveil the product we created, I wanted to show a quick video from our chief hardware designer, Zena, who's 4 years old. She's in the audience today, and hope you like it. Is that coming through the speakers? It is? OK. Thank you, Zena. And now to unveil the Grafana trampoline, I'd like to invite my son Bowden to the stage. Everybody give a hand for Bowden. You want to help me take it off? Voila. All right. So to go out of full screen mode here so we can go to our sensor here. And before you get on there, we're going to kind of tell a story here. So we're going to start with the first dashboard we ever created. Let's give it a try here. Go ahead, Bowden. Let's generate some data. All right, so as Bowden's jumping here, we're zoomed into the last 5 minutes here. I'm going to change this to, let's say, last 10 seconds so we can see some data. So what do you think? Sawtooth? Was Bowden's hypothesis correct? Pretty close? Yeah, pretty close. Looks like some teeth to me. So, so we kind of had this sawtooth or a waveform or whatever you want to call it. And what we really wanted to do was to have some way to do a high score of how many jumps per minute we had done. So, so Bowden, let's actually show off some of your Grafana skills here. What do you say? Do you want to come drive this? All right. So Bowden's going to hop up here. And the first thing we need to do, we discovered that if we try to zoom in while we're refreshing, get a microphone here for Bowden. What happens if we try to zoom in while we're refreshing? Does it work very well? Not really, right?
Not really.
Not really. So can you help me turn off the refresh? Let's just turn refresh to off. Yep. So we've got refresh to off. We always remember to hit apply, right? Daddy makes that mistake sometimes too, huh?
Yeah.
And let's change last 10 seconds. Let's go back and look at our last 5 minutes here. So let's look at some historical data. Can you actually stand up a little bit? Will that work? I'll hold your hand.
No.
That way people can see you, unless you want to hide behind there. All right. So now we've got our last 5 minutes of data. And Bowden, do you want to help zoom in so we can actually see some of that jump data? Great. So how many jumps do you think are on that screen right now?
How do I get this down?
Oh, just click like that. OK. So we got a lot of jumps there, right? Let's try to zoom in on maybe like 3 or 4 jumps. Let's pick some good ones. Pick like 3 or 4 of your favorites. Cool. So back when we were first doing this, I asked you a question, right? I said, let's pretend that you're a computer and you're just looking at this data. You never actually saw a boy jumping, but you were just looking at this screen. How many jumps on this screen are there? And what did you tell me?
1, 2, 5.
5, right? So a computer would be like, whoa, Bowden, how did you do that, right? Because a computer doesn't know what a jump means. But what were you actually counting when you answered that question?
Peaks and valleys.
Yeah, peaks and valleys. That was something we learned about when we were doing the temperature, right? But then we got to apply that knowledge with graphs. So we thought, okay, that's okay. We can make our computer program just count the peaks and valleys, because you told me that it changes when it goes from
ascending to descending.
That counts as what?
Up and down.
That counts as up.
A peak.
Right. So so we thought, okay, cool. We'll just make our computer program recognize when it changes from a peak to a valley. But what was the problem? What did we notice when we zoomed in and looked at the tops of these peaks?
There's little tiny peaks and valleys on the top of each peak and valley.
Yeah. So what would that do to our computer program? Would it give us an accurate count of our jumps?
It would give us way too many.
Way too many jumps, right? So we needed a different strategy. And we learned about something called, what was it called?
Sampling.
Sampling. And is that where we get to go to Costco?
No, but let's show the slide of it.
Oh yeah, we have a slide about what we didn't get to do.
Let's do the slide.
Yeah. So we love to go to Costco for samples, but we didn't really get to do that for this kind of sampling. What does this kind of sampling mean? Does it mean that we look at every single point of data?
It means that we take just some of it.
Yeah, so we figured out, we played with some different things, and we figured out that if we took a sample every 50 milliseconds, that it would filter out all of those noisy, tiny little peaks and valleys. And it wound up with something that looked like this, where we could count just peaks and valleys that were in between jumps. But then, did we want it to count if you just did like a lazy little pitter-patter on the trampoline?
We had to do big jumps.
Yeah, we wanted to count big jumps.
Not too big, but big
right.
enough.
So we learned about something called a
threshold.
Threshold, right? And so what does a threshold mean for this?
It means it has to go above the blue line to count as a peak, and underneath the red line to count as a valley.
That's right. Yeah, exactly. So when we put that all together, that's okay. So when we put that all together, let's show another graph of what that looked like with the counting the peaks and the valleys. And why don't you jump some more, bud? So let's show our version 2 of our trampoline here, of our graph. And I'll change this to last 10 seconds. And now we can see when we've got a detected peak, we have a red dot and or a blue dot, and a valley is the red dot. And guess where this idea for superimposing the points onto the line graph came from? From Bowden's earlier idea where he was playing with checking all those boxes, right? So that was an example of how I, as the teacher, got to have an experience of learning from my student and being like, oh yeah, that idea you had before, like that's totally something we could use now. So when we put this all together, we created a dashboard that looks like this. And it's counting not only the real-time jumps, and you can tell that some of the lazy ones didn't have a peak and valley, but what are we seeing on the bottom here? What's that bar graph showing, Bowden? Can you talk while you're jumping?
Yes, but the bar graph is showing. What is it showing?
Jumps per.
Jumps per minute.
Yeah, and why is that bar graph on the very right side going up?
Because I'm jumping.
Yeah.
Oops, that wasn't loud. Because I'm jumping.
Right. So, so we can actually have a high score here, and we play this game where we try to have our bar graph on the right beat the tallest bar, and this keeps us exercised when it's cold outside, right? So yeah, awesome. All right, Bowden, so you wanted to actually share some experiences from some of your other favorite moments, right? Do you want to talk about this one? I think you have kind of a stumper for the audience, right?
Don't tell them.
Oh, okay. Well, I won't tell them the stumper thing. All right. Well, you had a question you wanted to ask, right?
Raise your hand if you think that graph's going to go up.
So we have a temperature sensor in front of the fireplace. Raise your hand if you think the graph's going to go up when we put it there. Okay.
Raise your hand if you think it's going to go down.
Okay. Somebody's, I shouldn't have said it was a trick question, I guess. Somebody's onto that. Okay. And was there a third option?
Raise your hand if you think it's going to stay the same.
Okay. Nobody for that. Okay. So,
see, it went up.
But are those people totally right?
No.
Why not?
You're half right if
half
you
right?
said it was going to go up.
Because, what else did you figure out?
We put it underneath an ice pack, and it went down.
So even though it was in front of the fireplace, it still went down? Wow, that's not what I would have expected. So, anyway.
Wait, it's just in gray and black.
Yeah, I'm not sure why it's doing that. Anyway, thanks, Bowden. Let's give it a hand for Bowden. You can go sit back down with Mommy. Or you can stay up here if you want. So, yeah, you can come up too if you want. I wanted to talk a little bit about what motivates us. So Zena wants to come up here too for this. So sometimes in education or even at work, we learn about extrinsic versus intrinsic motivation. So extrinsic is where you do something to get a reward. Intrinsic is where you do something just for the joy of doing it. So Bowden had this cool idea that just a couple days ago, just before the conference, and actually, do you want to talk about this? Because this idea was super cool.
I had an idea to put water in a pot and then put the sensor on top and then put a lid on.
Yeah, so I had nothing to do with this idea. But Bowden had this idea, and we had never actually done anything interesting with the humidity sensor. We were just like, yeah, it's really dry in Colorado, big surprise. But Bowden had a hypothesis that the humidity would go up, and it did. But the really cool thing was that this was over a few minutes, but when we observed it over the course of like 24 hours, it did this really cool unexpected shape. And I think a lot of us know that in science, a lot of the best discoveries start with somebody saying, that's weird. So indeed, this was an unexpected result. It wasn't just this constant, going up. It actually reminded me of something I vaguely remembered from high school math of a logarithmic curve. And maybe somebody who understands environmental science can tell me why humidity rises this way. But it gave us so much more stuff to investigate that we hadn't even thought about. So anyway, so this I thought was a great example of intrinsic motivation, because Bowden just was so enamored with Grafana that he just wanted to use it for experiments of his own invention. So I thought, wouldn't it be cool if we could bring this excitement back to work as well? because sometimes, raise your hand if you've ever struggled to get a colleague to be as excited about Grafana as you are. Okay, yeah, me too. So, but we want our colleagues to know these tools so that when they need them most, they'll be familiar with them. So I tried something where I organized a game day. It's a concept where you get everybody in a room and you try to break stuff. And we elected a member of our team to be the chaos monkey and try to, shut things down and kill processes. And for a lot of the people in the room, it was their first time actually getting into the weeds with Grafana. And even though they had maybe used it before, sort of casually, this was their first time using it, to actually debug an incident in the moment. And the joy on their faces when they made a prediction about what was going to happen when we messed something up, and then seeing it in Grafana was actually really, really cool. And I got a lot of feedback from people that hey, I learned so much more from doing this than I did just from reading the docs. So just like that baby that experiences the joy of cause and effect from dropping food, or a kid getting excited about seeing their trampoline jumps, even senior engineers can see this cause and effect and be excited about it. And if this isn't just some idealistic fantasy that we have more fun, that when we have fun while we're learning, we learn better. It's actually backed by real science. So for some explain it like I'm 5 neuroscience, there's about 100 billion of these brain cells in your head. And when we learn something new, we're literally rewiring our brain at the physical level. We're creating new connections between the transmitting parts of our brain. Can you get down there okay? Okay. And the receiving end, called the synapse. And this allows us to not only to retrieve these new memories, but literally to think in new ways as well.
Can I talk about something?
What do you want to talk about, bud?
What you're talking about?
There's this concept called neuroplasticity, where our brain doesn't always work as well as it could or should, but this term describes the ability to reorganize these synaptic connections in response to learning. And as adults, sometimes we don't have as much neuroplasticity as kids, but that's not necessarily just a gloomy fact. There's actually good news that there's some peer-reviewed studies that show that when we combine learning and emotion, we can improve our neuroplasticity. So there's a fantastic book called Superbrain that I really recommend. There's a great quote that's backed by a lot of neuroscience that when you become passionate and excited about learning, the way children are, you can actually cause new dendrites and synapses to form in your brain physically, and your memory can be as strong as when you were younger. So wrapping up, takeaways from today: explain like they're 5 and learn like you're 5. So you're all the subject matter experts on Grafana and observability, and many of you are the go-to person in your org. But when you're helping somebody with doing something with Grafana or observability, try to resist the temptation to do all the work for them, and just because it's easier. Let them tinker, let them struggle, and if you can be there next to them when they have that aha moment, when it clicks, you can share in that emotional learning moment, and you can build some new synaptic connections yourself and improve your own neuroplasticity. Takeaway 2, don't just observe your environment, manipulate it. So exploit the fact that we're all hardwired to feel excited about cause and effect. And if you've got a dashboard with really flat, predictable patterns, organize a game day and challenge everyone around you to take control of the environment and make the graphs change. So knock down servers and cause a DDoS attack, and you might be surprised what you find, and the excitement of tinkering helps to solidify that memory of how the system works for you and your colleagues, so that when you're dealing with a real firefight, those neural pathways are already strengthened when you need them. And share the excitement at home. So in our industry, we've gotten used to kind of giving dismissive answers when people ask what we do. We sometimes say, computer stuff. We keep the website up and running. And we assume it's just boring or too esoteric for non-technical people to understand. But everybody here is so lucky to work with this technology, Grafana, that is actually approachable for non-technical people, even young children, even people who can't read. And Grafana is so fun to use that it can just really help to drive that intrinsic motivation and emotional learning. So if anybody's interested in building a Grafana trampoline at home, I've actually got a few starter kits with all the electronic components you'll need bagged up and ready to go. Come meet me. We'll be hanging out in the break area for a little bit after the talk. And I apologize in advance if it makes your TSA experience a little more hands-on. So here's my Twitter and my blog where you can find the plans and code for how to get this working. Feel free to reach out to me. I'd love to hear from anybody, especially those who might want to collaborate on future projects like this to help get kids involved in observability. Thanks.
Great. Thanks, Dave. That was great. And another round of applause for your assistance, I think. All right. I think we just have a couple of quick questions.
We have some questions.
Oh, sorry. Nope. No, I think we're right. No, we're all good. I think that's good. And I think
we're out of time?
We're out of time, yeah.
Okay.
So we'll, thanks a lot. That was really good. I thought that was excellent. I'm looking forward to doing something similar with my son when I get home. But that looks like a lot of fun. Okay. Let me just check, see who's up next. Okay, so next up we have a quick talk from VJ. From eBay, who's just going to give us a little bit of a rundown of how they use Grafana.
Hello. Okay. Hi, everyone. My name is Vijay Samuel, and I work for eBay's monitoring team. And roughly in the next 10 minutes, we're going to talk about how we started using Grafana at eBay. So many moons ago, we had our logging and monitoring team, and our charter was simple. Give out APIs that the users, that is the developers in the company, could use to instrument their applications with to send logs. We had our own developers who built out UIs for being able to search, view, and debug their issues. And metrics were no different from logs. We gave out a bunch of APIs to instrument the code. The important thing to note about this process was that the quality of the UI was entirely dependent on the person who's building the UI. I wouldn't call myself as a front-end developer, but I was the one who was building some of those UIs. And at one point, adding new graphs was so painful that I decided to do a proof of concept based off of Grafana. The first attempt was a literal hack. I took the master branch of Grafana and I modified the OpenTSDB data source to be able to understand our internal APIs. And we built out some dashboards, primarily scripted dashboards, but it didn't have all the complex features like templating or annotations. And this is how it looked like. This was about 3 or 4 years ago, and I think I tried out Grafana 3.x. So what was missing? It wasn't clean. It was a dirty hack. The code was not maintainable. Every time I tried to rebase, something would have changed upstream, and it was a little nightmare to maintain. Yeah, and like I mentioned, it didn't support things like templating and annotations. This POC was being used by some of our on-calls, and eventually it was lost in the sands of time until a few folks from our DB ops came and asked for Grafana support for our internal TSDB. And at that point, we pointed them to this fork, and the two gentlemen that I mentioned, Stephen West and Austin McReynolds, they did something fantastic. So they took the dirty hack and they converted it into a dedicated data source plugin, where it was still grunt-generated code, and they also added Docker support to the plugin. And I took that and I ran with it a bit more, where I had some Kubernetes deployment scripts for people to be able to deploy this. And every time someone asked for Grafana support, I would point them to this, these kube specs and tell them, go run it. And every time they asked for features, I would use my spare time and build out some features for that. And then at one point, a big breakthrough came. Our SREs also built their own custom UIs, and they decided they wanted to trash all of that and use Grafana to build out their experience. And Satish Sambasim, who runs SRE, he played a big role in this. Big shout out to him. This was the big moment. So they took it to the next level. They started to overlay a lot of data on their graphs. For example, any change that was happening that impacted the site, they dropped them as annotations on the graph. So they were able to catch interesting issues like a DNS flip caused errors to spike, and that was right there on the dashboard. They started providing hosted solutions. When I was maintaining it, I just handed over a spec, go deploy it, use it on your own, but they now added a standard where, okay, this is the portal you need to go to look at all your graphs. And they also started to build a lot of canned dashboards where developers can go and start looking at things. They also started contributing code in terms of features, and they also requested a lot of features themselves. But it was still a grunt-generated file. And at one point, they were like, hey, monitoring team, can you start supporting this for us? This is an example graph that, or a dashboard that they built. They have 4 golden signals, which they basically used to triage all the issues that were happening on the site. There were many more dashboards that they built. And after a lot of back and forth, we eventually said yes. And the monitoring team decided to take up Grafana as a first-class citizen in our offering. And this came with a whole new makeover. Now, there were seasoned UI developers working on the problem, and the first thing they decided to do was throw away that grunt-generated file and to do it right this time. They added widgets for being able to view logs and events. And they also provided a hosted solution, this time a lot more better than what the SRE folks did. And they also started adding a lot more features into Grafana, like being able to authenticate with our internal APIs, and also implemented annotations support for our data source plugin. So in the meantime, there are a lot of changes that were happening in the backend as well. We decided to get rid of all the custom APIs for being able to ship logs, metrics, and events into the platform in favor of more cloud-native mechanisms. For example, any person new to tech should be able to log to a log file. So we started advocating that log to either standard out or a log file. Let us know what it is, and we'll ship the logs for you. And the same for metrics. Instrument your code with Prometheus, and if you're running on Kubernetes, provide a few annotations saying that this is the port that we are exposing the metrics on, and we'll be able to collect and ship it into the platform. And do all of this as a community player. So we started investing a lot on open source. If we found a product to be worth investing on, and if we found gaps, we started contributing to them. One of them, which I'd like to call out, is the Elastic Beats project, which we have been constantly committing code back into. So in this entire journey, now we are at a place where we can say that we are slowly changing the dynamic of monitoring inside of eBay, and Grafana is playing a big picture in all of that. And so there were some interesting lessons that we learned. It's always good to be a part of the community. Anytime we saw that a feature was missing, we tried really hard to build it out in a generic way and try to give it back to the community. And only if there was friction from the community, we would manage an in-house fork. Creating dashboards is easy. When I first worked on UIs, every panel that I had to add had to have some code change go into it. Rome was not built in a day, but our custom data source plugin, at least the first stack, was definitely built in a day. So that's a big testament to Grafana. If a non-seasoned UI person like me could build it out in a day, then imagine how much power the product is giving to every developer. Cloud native is everything. Moving away from custom APIs and moving into more cloud native constructs has helped us to onboard more use cases than we could ever imagine. In the old world, if you had to onboard MySQL logs and metrics into the platform, the requirement would be, hey, can you change your code, the MySQL code, to have all our APIs to be able to ship the metrics and logs in? That was a straightforward no. But now, with cloud-native mechanisms, we can onboard any application into the platform. And last but not least, we should have adopted Grafana sooner. This was 4 years in the making. It's definitely a no-brainer. Thank you.
All right, thank you, BJ. Thanks for that. I don't think we have any questions, so so thanks very much. Next up, we have Alexi.
Hi, everyone. Are you kidding me? Can you see anything? Can you hear me? Oh, fuck. This is not what I'm... Hi, everyone. How are you doing? All right, so I'm here for 10 minutes to talk a little bit about time series analysis in Grafana. So who am I? I'm Alex. I do software. This is my GitHub. Please follow me on Twitter. I'm playing with Grafana for the last 2 years, and I founded a company called Corp Glory, and I do some kind of consulting for companies who build their solutions based on Grafana. All right, and you maybe know me because I have got the idea to pack your plugins into one bundle and made this nice thing. All right, so about the project. 1 year ago, I decided to go to a hackathon with my friends in Russia, to Gazprom, and I called Daniel Lee. Are you here? All right, and I said, all right, I want to play with time series data. Can you tell me what is the most interesting thing I can do? He said, you can try to solve false positive problem. Good luck with that. Nobody did it yet. All right. I took Grafana as basis. And you have two nice things in Grafana. You can visualize pretty much everything, and you have data sources which you can query. All right, so let's take it. And now we want to detect patterns. Just a simple task where you have one pattern which looks like a spike and another, and you want to distinguish them. So one is an Instagram post, and another is a backup, and you want to distinguish them. You're interested only in one of them. So it's not the only pattern you can imagine. It could be very different, and you want to detect all of them. All right, so the heuristic. So it is an application which consists of two parts. It's a Python app with plus Node.js and an app for Grafana. And it is very light. App. So it is a dashboard. Look at this. You just have a metric, and you can label a pattern there. And then you send it to something, and you get predictions. So each time you get this pattern, you would get an alert. If the detection is false, then you can label it. And so then you train the system not to detect this pattern. All right, so the server. I just said you about the app in Grafana where you label everything. And so this is the server, this Node.js Python app, and webhooks, the most interesting things. Somehow you query Grafana to get the metrics. This is a library which makes you able to query Grafana ends. That's it. This is what you can do this. All right. their ideas. So we just want to make it a tool which can solve this small problem, false positive. We cannot make all math for this, but we can make a tool which makes you able to be more productive with dealing with this kind of things. Last year we spent only to make it stable, and we want to make a small feature which works. All right. Maybe there are anyone who was on Manitrama in Amsterdam last year. All right. So from that moment, we made a lot of things. Most interesting that we started to support a lot of databases, like all of these, super feature threshold detector, and we played a lot with that Python process. We parallelized this all learning, and you can learn a lot of models at the same time. And you can install it on CentOS with RPM. And so this is the day when we released beta. After 1 year of development, this is the day. Hey, and you can download it now. It's stable now. You can download it right now. All right, so why I said that it is a platform? Grafana is a platform. Let's build another one. So this platform is a platform which makes you able to create your detectors to detect, for example, anomalies. You can make your statistics model on Python. I can show you. Whoops. So, as I said, it's just I haven't planned to do this. It's just two pieces. The analytics, it's a pure Python thing. This is analytics. And you can see all models there. And based on these models, you can use pretty much everything. You can put TensorFlow there if you want. So the idea is that we make a tool where you can process time series data and send your detection back to UI. All right, and you can make your plugin which uses API. For example, you want to detect anomalies in text or geospatial data. You can make a plugin and send data to your detector. Right. We want to make a product and offer you to host Hastic. We can host Hastic for you and install Hastic for your infrastructure and to integrate to your product. Now a lot of thanks to Grafana Labs. Thank you guys a lot. American Consulate. I get my visa to US yesterday. My team, thank you guys. They work hard to make this release better today. My girlfriend, this is her Instagram. Manitrama, thanks a lot Manitrama. Please consider to go to Manitrama this year in Portland. Thank you guys. Jason, I hope you see it. And adopters. We have 4 companies and they test Hastic. Please test Hastic, and I will personally work with your case because we have only 4 cases real. Thank you guys. Please like me on GitHub.
Just one quick question. Does Hastic process data directly from the data source or via Grafana?
Via Grafana. We are working on direct access.
That's great. All right, thank you very much. Next up, we have. Let me check. We've got Jordan from Amgen, who's going to give us a little talk on Are You On Call? I hope none of you are. I think I am.
Okay. Thank you. Where did that go? Hello, everybody. Let me get set up here.
It was terrible.
What is that? Okay. Can everybody see that okay? Is that coming in black and white there? Yes? Oh, interesting. There was another adapter to use, but it's a little weird. Yeah. So I'll go ahead and introduce myself while we're waiting for that. There was a different adapter up here earlier. So my name is Jordan Hamill. I'm a software design engineer at Amgen, which is also based here in Southern California. This is my third GrafanaCon, and I'm very excited that Grafana came to my backyard this year. I'm going to talk a little bit about a question that I think is always on our minds if you've been in operations or if you currently are in operations. I'll go ahead and do the show of hands questions now. But how many of you are on call like regularly? Quite a few. And how many of you manage teams that are on call? Yeah, also quite a few, right? So I think like on call is something that doesn't get enough attention from a measurement perspective, and I think that's kind of a thing that we're going to try to go through quickly here. We'll go ahead and go with our grayscale and see how we do. Quick background about Amgen. Amgen is it's a values-based company deeply rooted in science and innovation to transform new ideas and discoveries into medicines for patients with serious illnesses. Amgen is an end-to-end biotech company, and our mission really is to serve the patients. If you'd like to learn more, please go ahead and visit our website on amgen.com. So yeah, let's see if we can get back to color. Okay, I think we're going to be all right. That's still... Still grayscale? Okay. No worries. Let's see. Okay, so we're going to just quickly talk about a little about an imaginary ops team at Amgen. I'll introduce Sally, Harry, Ming, and their very important customer, Judy. We're going to talk a little bit about how to collect this kind of on-call data into Grafana, and I think that there's a lot of value in collecting that, no matter the size of your team or the size of your organization today. We're going to look at it from kind of two categories, the operations point of view and then also the on-call management point of view. And so to kind of get started, let's talk about how we start collecting things from the beginning. So this is real data, even though the names are fake. But you really just got to start collecting and determine what your reliable source of your on-call rotation and the call data is. Some people manage their on-calls like with a SaaS provider. There's several here that have been at the Grafana conference. You can look at Grafana integrations and find a ton of different ways to manage your on-call teams. You could use things like CSV files or Google Calendar. If you have Office 365, you can use Outlook. Whatever you're doing today, there's a way to get it in. So the way I'm doing this data is from Telegraph or FluentD. I've been playing a lot with FluentD in the last year, so I use Ruby just to run like a Telegraph execution to get the JSON, parse it into Influx, and then that lets me store the data. So I choose an interval that makes sense for me, and depending on how many teams you have or how frequently your on-call is changing, that's up to you. One little gotcha, just a reminder that your telephone numbers are often strings because of things like plus signs and hyphens, and Telegraph will ignore string fields by default, so you need to kind of adjust for that. So what you're seeing at the bottom is just like an example of Ming and Sally and Harry's data coming in compared between Influx and Elasticsearch as a combined output. That was just a way for me to kind of get an idea of like what am I getting in my responses, and then can kind of play with it from there. So let's take a look at the operations use case. Judy here says that the app errors are up and the users are feeling down. It's the middle of the night. Who's there? Sometimes we have external teams that aren't reliant on our on-call schedule, and they don't know exactly who to reach out to when something has happened, even though, in theory, you should have had like a distribution list or something where the on-call person is already taking care of a specific problem, right? So what can Judy do? Well, technically, they could just expand a row. So on the bottom, if we have our on-call details here, and there's a little panel row, if you guys don't use rows in Grafana, it's great, because the queries don't actually fire until you click on the collapsed panel. And we can see things like the current on-call contact is Ming, and the additional contact info, the time that Ming started the on-call rotation, and as well as when that rotation will end. And then we can see this particular error rate on this application has already gone up to escalation layer number 2. So we seem to have a dropped incident. And this connects the user, right? Because in the end, from an operations perspective, you want to connect people that have questions to the people who can give them answers. Whether or not this turns out to be something that's terrible or not, what I recommend is to think about your on-call data should be taking actions by people, right? So if we're on call and the people are on call, you should be putting this data with your dashboards that have your service level objectives. So depending on how far along you are in the maturity of thinking about your business metrics and where you really need to get a person involved, you can decide to like build your dashboards with an extra panel, a panel row at the bottom, and just fill that in. So say, at a company the size of Amgen, we have, dozens of teams. We can just find a tag identifier and then make this all templated and so that you get the right on-call person for the right application. Let's take a look at like a management use case as well. So if you think about like some of us that have been on call for days and days at a time, a lot of times we kind of go off of our feeling of whether we're feeling burnt out or not. But imagine you had a graph where you could actually see the person's face that you're going to have to call and say, hey, get up and fix this problem. And this is also a management use case to say, what if we know that in the course of a year, everyone shared their equal time on call, but the on-call experience wasn't exactly even, right? We see that Sally actually had like over 70 incidents to respond to, and that is not necessarily a fault of Sally's, but it could be when you do your release schedules, when you update your applications. Could be specific outages at different times. Maybe the rotations were uneven, but they spent the same amount of time. So I think like not letting people burn out on call is something that it's being talked about in the industry, but I don't think we really focus on it enough from like a visualization perspective. We've been like told for the last 10 years to graph all the things, but when are we going to start graphing the people? And that's kind of what I think is the answer to the question why. The operations use case, again, it's connecting people faster, reduce the friction to use context switch back to wherever you keep your on-call data today, like whether that's a file or an actual SaaS platform. It also kind of starts to help you think down the process of getting revealing out who's building and running the code that you actually have in production. Some organizations, they have a separate like 24-hour NOC team or an SRE team that isn't necessarily the only people that have to be on call, but you need to be able to connect those people and those users. So I find that there's some use cases there. And then just like democratizing the people behind the metrics. It's a chance for you to come into the forefront to say like, it's easy to communicate, easy to find people, but at the end of the day, Grafana is really a collaboration platform, and that collaboration it's very visual, and it gets people into the system, and it's better to know like who's behind the systems that are running. And from a management perspective, like you can always find room to improve an on-call rotation. Previous to being in the position that I'm in now, I was in management at Amgen for a few years. Coming back into the individual role, it's really obvious to me that managers don't spend a lot of time thinking about on-call rotation. If you are, great, that's awesome. But put it in Grafana, and I think you'll find that there's a valued use case there. And something I like to think about, like blameless postmortems. It's like if you're trying to say, don't blame the person, but blame the system. Adrian Cockcraft at reInvent this year reminded people again that failures are a system problem, but it's the people that are on call that are still part of your system to fix those problems. And so as you're going down the path of what the SRE model of removing away the repeatable errors and automating away all of the toil that your on-call teams deal with, it's really important to recognize that the flip side of that is actually recognizing that you've achieved your SLO. How many times have you been congratulated in the last month for 99% uptime? Anybody? No. So put a face to it. People that are in business, they want to know a little bit about the operations teams who can seem very distant from the business sometimes. I think it gives you an opportunity to think about like where in your organization it could fit. And it's really simple to graph in Grafana, as we can see. And kind of the takeaway is that your on-call people are definitely part of your system. You should measure the metrics to support them. And I think that Grafana is the right place to do it. And don't overcomplicate it. Find a simple way to collect the data, and I think that you'll end up with a happier on-call experience. And for those of you that have had like the phantom like buzzes on your cell phone in the middle of the night thinking someone's calling you, this gives you a chance to have a conversation where instead of just thinking about, oh, I feel like I'm always being called in the middle of the night, now you have the data to show. And I think that is what we're all trying to do with our application metrics anyway. So thanks again to the Grafana Labs and the Grafana community. Amgen is hiring in software dev, test, and ops. We're located about 20 minutes north of Malibu here in Southern California. So feel free to contact me, and thanks a lot.
All right, thank you, Jordan. Yeah, I don't think you have any questions, so thank you. But it's always good to remember to watch the watchers. Okay, next up we have Hendrik, who's going to give us a talk about some IoT stuff that's been happening in Africa.
Test, test. Okay, cool. Well, did we not have an HDMI adapter? No. Oh, sorry. Yeah, I didn't see it. Yes. Cool. All right. Yeah, good to be here. My name is Hendrik. I'm the co-founder of AMP Technologies, and I want to talk to you guys today a little bit about basically the impact that IoT had on a couple of rural electrification projects that we have been involved in over the last couple of years, but also a little bit on the way forward in this regard. And in order to start, I want to take you to a very particular place. So I really want to take you to a village in Tanzania, which is a very rural village. The village, the name is Changombe. It is in the Manyara region of Tanzania, and it has about a population of about 2,000 people. And it didn't have any access to electricity till 2017. And as you can see, it's actually a very beautiful place. Well, the problem with the access of electricity was eventually solved in Q1 of 17 by a project developer called Rafiki Power. And what they basically did is they built a solar mini-grid in that village to provide electricity to that village. And not just the solar system, but they really provided a distribution grid to individual households and businesses in that village. And so the main goal of those kind of mini-grids is that you want to increase the standard of living and give people in the village opportunities that they didn't have before. And I just want to share a couple of pictures of what this mini-grid actually accomplished. So people were now able to run laundry services in those villages. They were able to cold store, drinks and foods, but then also things like vaccinations and these kind of things. They will also come up to extend their businesses by having electrical appliances for a hairdresser shop, for example. But I think most importantly, what those villages, or what the goal is of the electrification of those villages, is enhance the economic activity in that village and the economic output. So this is why it was very important that the technology was able to make sure that equipment like welders or drillers and even corn grinders were able to operate. So this was all enabled by this solar mini-grids. So a solar mini-grid usually consists of a centralized powerhouse where you have solar panels on top, for example. Then a lot of times you just have a container where you have inside all the power electronics of that village, and then you also have some battery storage for the night. Then you have usually just 230 volt, 50 hertz electricity grid that goes to the individual households and businesses. And then a lot of times you actually have smart meters installed at each of the individual households. Mainly, it measures data like voltages and energy consumption, but it's mainly used also for payments and for making sure that customers can have basically a prepaid plan on how to consume electricity. But in general, you have two places where you would definitely have some kind of measurements and some kind of technical data that is gathered. So first on the consumption side at the smart meters, but then also on the power electronic sides, which is usually the battery inverters and the PV inverters. And what most people also don't know is that most of those villages actually have a pretty good mobile data connectivity, so it is actually possible to access this kind of data. And this is where our company comes in. So our company currently monitors more than 100 of those kind of solar mini-grids across multiple countries in Africa. And by doing so, we can use the operational data to help developers of those kind of mini-grids improve many activities across the whole value chain for those developers. So it starts with project finance by making those projects more bankable, by proving that you can actually deliver what you promised. But then also things like system design and engineering for benchmarking, benchmarking systems against each other, technologies, and so on. But maybe most importantly, the technical maintenance and the operations of those kind of systems is usually very complex. And so how are we doing it? It's relatively straightforward. So we have two ways in which we can gather data from those systems. Either we install a local gateway at those systems that would then talk to each of the individual devices and sends the data in the cloud, or we have a direct API connection to some of the equipment vendors that have their own cloud platforms where we tap in and gather those data points. We store all of the data in an influx database. We apply some analytics and alerting on it with capacitor mainly, but just recently we also started with another open source framework which is called LoudML, which we use for anomaly detection. And then we visualize all of this data in Grafana. And now I want to get a little bit more hands-on on two use cases where it actually proved very, very helpful. So one of the things that is good to emphasize is that those villages are really remote, and whatever can be done to not going out there and try to fix things yourself is extremely valuable. This is actually a picture of a former colleague of ours that was trying to reach one of the villages in Tanzania and well, got stuck in the mud, and that was just the short rains in Tanzania. In the long rains, it's even worse. Yeah, and so one of the problems where we actually use Grafana is actually one that you see here. So what you see in this picture is the smart meter voltages of one mini-grid, where each of the points is an individual household, and the color represents the voltage at this point. And what you can see also in the graph, by the way, is that a certain part of the grid had like some kind of voltage drop, and the other parts didn't. And if you know how you build your electricity grid and your grid topology, it's quite straightforward for you to identify remotely where this problem is, and that it's potentially a cable issue. So you were able to localize where this cable issue is, and then how does this translate to on the ground? It's literally, you go to the place where you localize it, you dig out the cable, and then in this particular case, you find that the cable actually was damaged. You fix the cable, and this is how it looks afterwards. So it's just very good also in terms of validating what has been done on the ground and that it actually worked. So that was the first case. The second case brings us back to the village that I mentioned at the beginning, to Changombe. And there, let's look at the solar data of this village. So in this graph, you see two things. So you see in green the battery state of charge. You can see it's about 3 days of data. And then in yellow, you would see the solar power. And one of the things that you would notice is that once the battery reaches the maximum state of charge, the solar power gets curtailed because the load is not enough and the battery is full. So what do you want to do with the solar power? You can't use it, so you curtail it. So there's a lot of unused PV power a lot of times. Well, at the same time, there was a new project coming along in this village, which was a water pumping project, which was commissioned in 2018. And it had a big tank with about 10,000 liters of capacity. So, I mean, this is great, right? We have excess solar energy, and we have a water tank that needs to be filled with, an electric pump. So why don't we come up with a solution that would then make sure that the tank is just being filled with this excess energy? And this is exactly what has been done. So what you see in the two graphs below is in red is the grid frequency, and in blue is the water pump when it was operating, so the power consumption of the water pump. And what you see here is that whenever you had excess solar electricity, the grid frequency would rise. This is an off-grid system, something that is very, very common for communication. This is usually done by the battery inverter in an off-grid energy systems. And this can then be taken at the water pump by a frequency controller that would monitor the grid frequency and would react to a higher frequency by switching on the pump and by pumping the water into the tank, which is exactly what happened. So at the end of the day, this led to lots of happy faces and like a very successful water pump operation in this village with about 400 liters per hour that was actually being able to be processed. Well, and that's it. That's all that I wanted to talk about. We are a young startup working on this for about 8 months now. As I said, operating about 100 mini-grids. And we are hiring at the moment, so if you guys are interested, just hit me up. Thanks.
All right, thank you, Hendrik. That's definitely some interesting stuff you've been working on.
Cool.
I don't think we have any questions, and we're running a bit behind, so we'll keep moving on. Next up, we have Sean, who's going to give a little talk about live data from streaming data sources.
Test. Cool. My name is Sean Lafferty. I work for Sev1. I'm going to talk about live streaming data sources in Grafana. I'm going to talk about our use case for them, why they're cool, and how anybody else writing their own data sources can do the same thing. So Sev1, we've been in the network monitoring space for a long time. It's about 13, 14 years now. Our traditional product is a racked and stacked physical appliance that connects lots of SNMP, NetFlow, that sort of stuff. But we're deployed in some of the largest networks in the world, a lot of carriers, telecos, CSPs, financial firms. So we're familiar with collecting large amounts of data. And looking forward, we're close to the release of a new SaaS monitoring product that we built from the ground up, completely new tech. And the design principles behind this new product are we want to solve a lot of the pain around some of the largest Prometheus deployments. So we're specifically targeting extremely high frequency data, extremely high cardinality data, and also support streaming as a first-class citizen. And as we started to build this out, we realized we needed a good way to visualize the value of having this high frequency data in our early POVs. And we started using Grafana like a year ago to do some of our own self-mon because we didn't have that many front-end engineers in our organization at the time. And we fell in love with it. We started using it more and more. But we realized there was trouble getting like the wow factor of having live sub-second data when Grafana has like a 1 or 5 second timer. So we started turning the timer lower and lower in Grafana and trying to render the data faster and faster. And it's not a great UX. And we also started to have other problems where if you have like data at 100 millisecond frequency, you start getting like 30,000 points over the wire like every 1 second, 2 seconds. And it's not great because we have to pay to pull that out of our back end. We have to pay for the egress of that. The user has to bring that over their network. So it's really in everyone's best interest if we can stream. So we started to ask ourselves, how difficult could it be for Grafana to live stream this data for us? Can we do it in our data source? Would we have to fork Grafana? Would they be interested in taking this upstream? So we started to dig in. We looked around. And it turns out it was actually really easy. But there is an asterisk next to that because this isn't something that's well documented in Grafana, and I'm not sure if it's even really officially supported. But the data structure that you normally send as a data source, you can wrap that in an RxJS observable object. And this exists in the Grafana code base from a time when the team did some experiments around WebSockets and decided to leave this feature in here. So what you can do is you can put your data in the observable object, and you can hook that object up to a long-lived HTTP request. And you can use like the Fetch API or like a modern HTTP library like Axios or something to do that and feed that data into the observable object. And what you get out of that is you, as the data source, can implement live streaming without having to make any core changes to Grafana. So I'll show you what that looks like. Sorry, the network kind of cuts out sometimes, and I have to refresh this. So on the left, you see we're looking at the same data in these two columns, but the two panels on the left are the 5-second default refresh in Grafana, and the ones on the right are the live data. And you can imagine if we have a whole dashboard full of these requests at sub-second, like 100 millisecond data, which this is, then it's so much data to transfer over the wire, and we don't have to resort to buffering the data like people talked about in other presentations or stuff like that. So it's been a great experience for us as we're trying to build this product that can handle millions of data points per second, and we need super granular insight into how our message queue is performing and how ingestion pods and stuff are scaling up and down. It's been a godsend for us to use this, and I've heard a lot of interesting use cases in the conference over these last 2 days of I think other people that could really benefit from having this live data, like some of the people that do IoT and have big periods of no data, but then lots of super granular dense data, or some of the emergency services people who like lives literally depend on seeing this data as fast as possible. So I would love if more people experiment with this. I would love to work in the Grafana codebase to make this more of a first-class citizen because there are some hiccups, as you can imagine. So the panels never finish loading because the data is always coming in, so a lot of the graph interactions don't work. So like zooming and things don't work. It's really easy to destroy the browser. Like once you're using sub-second data, it's just like a cannon pointed at your foot. Because like in one of our examples, we had 10 metrics at 1 second. If you're repainting every time they come in, you might be repainting like every 100 milliseconds. So you need a way to throttle your writes into that observable object, and there's probably better ways to do that, which I haven't explored fully yet. And it's also hard in Grafana to like control the life cycle of the open streams because, like I said, the panel like never finishes rendering. So it's hard to know like when you make an edit and change the query to kill the existing stream and start a new one. So I like also haven't figured out the best way to handle all that, but it demos well and it's really exciting, and the people we show it to and our POVs love it. So that's something we want to keep investing in. And yeah, like when you have live data and non-live data together, like the UX of how the window slides and how the other ones refresh, there's some complexity around that. But I haven't, our actual Sev1 data source isn't ready to be opened yet, so I tried to like pull the most important bits out of that and dump them quickly this morning in like a minimally viable streaming demo. And this code is like almost pseudocode at this point, but I just wanted to have something that people could look at if they were eager to start experimenting with it. But I'll flesh this repo out some more with some better use cases and some of the fixes and stuff that I've learned in my time of doing it. So that's it.
All right, thanks very much. We're running a bit behind, so we'll keep moving forward. Lastly up, we're going to have our spiritual leader, Torkel, come back out. So big round of applause for Torkel.
Hello, let's see. Okay, so I don't have a lot to say. It's just a few closing remarks, a farewell. But before that, I want to just thank all our sponsors. They're kind of responsible for making the ticket affordable, and it's super glad for the partnerships and sponsors that made this conference possible. I also want to thank all the speakers. We had a ton of speakers this year, and I'm super glad for all the hard work they put into preparing and performing all the talks this year. So I also want to thank everyone who bought angel tickets. So the last couple of tickets we donated to the Electronic Foundation, Frontier Foundation, and we also matched that. So a huge thank to everyone who bought those tickets. So for these last slides, I've developed or started using a highly advanced visualization tool in Google Slides and done some amazing line graphs. You will be amazed. So I just wanted to kind of visualize my feelings over the last couple of days and my kind of measurement of your feelings as well, talking to people over the last 2 days. So I think a lot of people had a ton of fun. I've had a ton of fun, especially kind of this last talk by Dave teaching Grafana to kids. I thought that was amazing. I have a small toddler at home as well, and I want to put a sensor on her trampoline. That was a ton of fun. I also think we had learned a lot. We had a bunch of more in-depth talk on Grafana itself this year than previous Grafana cons, and I think that's been sort of one of the feedbacks we had, that we want to have more in-depth talk or more in-depth content on Grafana itself, what you can do, how to use it, and that's something I think we have done pretty well this year. But most of all, kind of my love and appreciation for everyone, the community, the Grafana users has also increased a ton. I mean, 5 years ago, I could not have imagined to have kind of conferences at this scale with this level of kind of appreciation, interest, and love for this kind of little tool that I was working on. So a huge thank you for coming here and showing that interest. It means so much to me. Last GrafanaCon, I invited everyone up on stage, everyone at Grafana Labs up on stage. So this year we're about sort of more than doubled. So I tried to do the same, but the stage would break, I think. So we're not going to do that. Instead, I'm just going to sort of give you all a super big thank you for coming here. And see you all at GrafanaCon 2020.